Hello viewers, in today's session we are going to discuss an important problem related to Rolle's theorem, right? And here we'll verify the conditions of Rolle's theorem for the function f of x is equal to sin 6x in the interval 0 comma pi by 2, and we'll also find the value of c at which the tangent is parallel to the x-axis, right? So before solving this problem, let us quickly revisit the statement of Rolle's theorem. So the Rolle's theorem says that if we have a function, say y is equal to f of x, which is defined in some interval, say a comma b, and this function y is equal to f of x is continuous in the interval that is a comma b, and the function y is equal to f of x is differentiable or derivable in the interval a comma b, and f of a is equal to f of b, right? So if we have a function y is equal to f of x defined in some interval a comma b, and if this function satisfies these three conditions, that is f of x is continuous in the closed interval a comma b, and f of x is differentiable in the open interval a comma b, and the value of the function at these two endpoints are same, then Rolle's theorem says that there exists a point C between A and B such that the derivative of this function at this point is equal to 0, right? So it implies that f prime of C is equal to 0. So when the derivative of a function is 0 at some given point, then it implies that the tangent is parallel to x-axis at that point, right? So here we are taking the point x is equal to c, which lies between a and b, such that f prime of c is equal to 0. So it implies that at x is equal to c, the tangent is parallel to x-axis, right? So let us now come to this problem where we are given the function f of x is equal to sin 6x in the interval 0 comma pi by 2. So if we compare this function with this one and the interval this interval with this one, then we have the value of a as 0 and the value of b is pi by 2, right? Now let us see the conditions one by one. See, the first condition is continuity, right? Now this is a sine function, right? And we know that the sine function is a continuous function in its entire domain, right? So here sin 6x is continuous in the interval that is 0 comma pi by 2, right? Okay, so now the second condition is the condition for differentiability or derivability, right? So now if we differentiate this function, that is f prime of x, then we have d by dx of sine 6x, and this is 6 times cos of 6x, right? And we can easily see that the derivative is 6 times cos 6x, which is or which exists in the interval that is 0 comma pi by 2, right? So the derivative exists in the open interval 0 comma pi by 2, or in other words we can say that for each value of x lying between 0 and pi by 2, the derivative has a finite value, right? So the derivative exists. So it implies that the derivative of this function exists in this interval, or the function is differentiable in the interval 0 comma pi by 2, right? So now let us consider the third condition. So now let us find out f of a. So a is 0, so we have f of 0, that is sine 6 times 0, this is sine 0, and sine 0 is 0, right? And what is f of b? F of b is f of pi by 2, and we have sine 6 times pi by 2. Here we'll take x is equal to pi by 2. So we have this is 2 times 3 6, so this is sine 3 pi, and sine 3 pi is 0 because sine n pi is equal to 0 for all n belonging to the set of integers, right? So we can see that these two values are same, that is f of 0 is equal to f of pi by 2, right? So from this discussion we can conclude that this function f of x is equal to sine 6x, it satisfies all the conditions of Rolle's theorem. So now this function f of x satisfies all the conditions of Rolle's theorem in this interval. So it implies that there must exist at least one value of c which lies between a and b, and here a is 0 and b is pi by 2, so we have this inequality, right? So there must exist at least one value of c such that f prime of c is equal to 0, right? And we have just seen that f prime of x is equal to 6 cos 6 x, right? So here we have 6 times cos of 6c, that is equal to 0. So taking x is equal to c over here, right? So now we have cos of 6c is equal to 0, and here we have a trigonometric equation, and we have to solve this trigonometric equation to get the value of c. So here we'll make use of an important concept from trigonometry, that is if cos of theta is equal to 0, then theta is equal to 2n plus 1 times pi by 2 for all values of n belonging to the set of integers, right? So whenever cosine theta is equal to 0, then theta must be an odd multiple of pi by 2, right? So here we have cos of c is equal to 0, so our theta is 6c. So we have from this expression 6c must be equal to 2n plus 1 pi by 2, right? So now we can write the value of c as 2n plus 1, and here we have pi over 12. So we'll multiply this 2 with this 6, right? So this is the general value of c where n belongs to the set of integers, right? But we have to find the value of uh, that value of c which lies between this interval, that is 0 comma pi by 2, right? So here n is 0 plus minus 1 plus minus 2 plus minus 3 and so on, right? So here we'll take some values of n which falls in the interval 0 comma pi by 2. So now let us first take n is equal to 0, right? So the value of c is 2 times 0 plus 1, and here we have pi by 12. So this is 2 times 0 is 0, so we have 0 plus 1 1, this is pi over 12, right? And if we take pi over 12 into degrees, then pi over 12 is equal to 15 degrees, right? Let us take n is equal to 1. Then the value of c is 2 times 1 plus 1 over pi by 12. And here we have this is 2 plus 1 3, and 3 pi over 12, and 3 pi over 12 is pi over 4, that is 45 degrees, right? Let us take n is equal to 2, right? So when we take n is equal to 2, the value of c is 2 times 2 plus 1. And here we have pi over 12. So this is 4 plus 1, 5. That is 5 pi over 12, right? And when we convert 5 pi over 12 into degrees, then we have here 75 degrees, right? So only n is equal to 0, 1 and 2 gives us those values of c which falls in the interval that is 0 comma pi by 2. So here pi by 2 may be taken as 90 degrees, right? And we can easily see that 15 degrees, 45 degrees and 75 degrees falls in this interval, right? So the values of the admissible values of c in Rolle's theorem are given by 15 degree, then 45 degree and 75 degrees, right? So here we have three values of c in this interval, that is 0 to pi by 2, where the tangent is parallel to x-axis, right? Or in other words, where the derivative of this function vanishes, right? So this is how we can verify the Rolle's theorem for this function in this interval, right? And remember, the values of c are given by pi by 12, which is 15 degrees, then pi by 4, which is 45 degrees, and 5 pi over 12, which is 75 degrees, right? And all these three values, these belongs to the interval that is 0 to pi by 2.